Hey guys, I'm Sarza, this is Mateo, this is Mark, and we're going to talk to you about geotechnical engineering.
A very good quote that geotechnical engineering has is, everything is supported by soils and rocks. Geotechnical engineers are responsible for that. Anything that isn't supported by soils or rocks either floats, flies, or falls down.
Geotechnical engineering is the basis to all civil engineering projects, and without it, nothing could be done.
So, in general, geotechnical engineering is a segment of civil engineering that connects the relationship between soils, rocks, and underground water to the design, construction, and operation of civil engineering projects. Geotechnical engineers start with the testing of the environment in a site at which a project is to be located. Samples are taken from the site and brought to a lab to be tested through many different rigorous tests to view if the environment is suitable for a project. The geotechnical engineering area in civil engineering is relatively unstructured and provides freedom for students and their graduate committee to develop a plan of study that will meet individual goals. Geotechnical engineers are in charge of land transportation, deep foundations, landslide prevention, earthquake assistance, underground infrastructure, dams, dikes, and levees, offshore structures, ground improvement and contaminated site remediation, deep excavations, and scour and erosion mitigation.
Another implementation of geotechnical engineering is shallow foundations. Shallow foundations are used in firm soils or when loads are light. They are used to transfer loads to the ground underneath a building site. However, if shallow foundation is built improperly, there will be failure. The Leaning Tower of Pisa is an example of this. It was built on a shallow foundation which failed due to being built on a layer of clay that could not handle the load. Another form of foundation that deals with geotechnical engineering is deep foundations. This form of foundation is used in an area where there is very weak soils or where there is a very heavy load. This is done with driven piles that are usually used as a form of deep foundation. Cofferdams are further used in geotechnical engineering to allow construction of a project where water could be found. They are used to protect the site from being ruined by flowing water while construction is going on. Cofferdams are often used when building dams to allow construction. An example of a cofferdam was used when building the Hoover Dam. One of my favorite things that geotechnical engineering is used for is geofabrics. These are used to reinforce soils from sliding and breaking apart, while also allowing for much better filtration and drainage. Geofabrics can be found under many roads and buildings to make sure that soils can drain properly and stay together to prevent landslides.
To name just a few challenges geotechnical engineers face, there are earthquakes, landslides, groundwater contamination, and depletion of water tables. Earthquakes are highly feared by geotechnical engineers due to their unpredictability and sheer power. And landslides will occur when soils are weak and start separating in different ways. Polluted groundwater can often lead to environments that are not suitable for a project to be built on. Also, the depletion of water tables can lead to failures in the ground above it that will make it cave inward. There are many different companies that geotechnical engineers could work for. For instance, there is GEI Consultants, Tetra Tech, HDR Incorporated, AECOM Technology Corporation, and Jacobs Engineering Group, just to name a few. These jobs are all around the world. Hot, cold, wet, dry, doesn't matter. If there's soil, there will be geotechnical engineers.
Our new